Hello, statistics and pre-calculus. So I know that 5.1 has gotten a little bit complicated, especially since we've gotten into actually combining everything together. So in this video, I'm going to kind of review a little bit and hopefully also go through a problem for you or with you guys that you either did in class if you're in section 1 or did at home if you're in section 3 on Desmos. Also, I changed the problem up a little bit. So section 3, this will look like the one you see, but section 1, it'll look a little different. So just bear with me. I wanted to start out, though, by hammering home again our general equations. We have two. They are the same equation. It just depends on how you like to look at it. This top one is if you want to put all of your y variables on one side, the things that change the vertical axis on one side, and all of your x variables are the things that transform horizontally on the other side, right? The other one is if you just want y by itself and you want everything else on the right side of the equation. It is totally up to you which one you choose. It does not matter. I find that this one is easier to understand because in this one, all of the signs and multiplications behave the same way. Here, you kind of have to flip your thinking depending on whether you're going vertical or horizontal. Let me explain. So there are 4 things we know how to do. Technically 5 if it's a reflection. But let's just talk about our 4 major ones first. So we have translations. We can go up, down, left, right, okay? If we go left and right, that is a horizontal translation. We're moving along the x-axis, right? If we're moving along the x-axis, we're acting on x. So we are going to be either, if you think about this equation, on the right-hand side of the equation, inside the parentheses, so that would be variable h. Or down here, since everything's on the right-hand side of the equation, just think about it being inside the parentheses. It's h. Now, there is already a minus sign here. So remember, if we are moving right, we are moving in the positive x direction. Our h will be a positive number. So say we're moving right 2, h will be positive 2, but it's x minus h, so we're going to have x minus 2. If we're moving left, h is negative if we're moving left, right? So if we move left 2, our h is negative 2. Since there's already this minus sign here, though, we're going to be x minus negative 2. And when we have 2 negatives, we have a positive. So we're actually going to be x plus 2. So again, that behaves almost the opposite of what you think. If it's x minus a number, then it is going to be moving to the right. If it is x plus a number, it's moving to the left. So bear in mind that everything behaves a little differently than you think. Now, we can also move up or down. Up and down translations are along the y-axis, which means we're acting on y. That means if you use this as your general equation, we'll be acting on the left-hand side of the equation. If you use this, we will be outside of the parentheses. So our variable here is k. Now, if we move up 2, k is positive 2. If you're looking at this equation, that means that we'll have y minus 2. So just like our x translation, it behaves the opposite of what we think. If we move down 2, we will have x minus negative 2, y minus negative 2 or y plus 2. So that behaves the same way as our horizontal translation does. However, we have to invert things to move them to the other side of the equation. So to get k over here, we had to add k. So if you use this equation, it behaves the opposite of x. And so if you move up 2, k is positive 2, and we have plus k plus 2. If you move down 2, we have negative 2. That means we have plus negative 2 or minus 2. So you see what I'm saying when I say that I think this one is easier because you have the same behavior for k and h. But if you like this one, it is totally okay to use it. It just involves a little bit more thinking. So the other thing we can do, right, girls, is either stretch or compress horizontally. So again, horizontal along the x-axis. That means we are going to be acting on x, right? That means that we are going to be inside of the parentheses and we will be on the right-hand side of the equation. So our variable here that we'll be changing to do horizontal dilations or horizontal stretches and compressions is b. Once again, this behaves kind of the opposite of what you think. If we are stretching by a factor of 3, our b equals 3, that means we will have x over 3, right? So if we are compressing by a factor of 3, what we're really doing is dilating it by a factor of 1/3. So our b is 1/3. If you have x over 1/3, that is the same thing as 3x. Another person in one of our classes did it in decimal form. So she put x over 0.33. That is also correct. If that helps you better than trying to do it differently, if you'd rather just do decimals so that it's always in the denominator instead of flipping it, you can, but just know that you may see problems where you have something like 3 times x. That is a compression. So again, just like our addition and subtraction seem backwards, our multiplication and division seem backwards. If it's a stretch, we're dividing, and if it is a compression, we are multiplying. So final thing we have is our vertical stretches and compressions. So same kind of deal here. If we stretch vertically by 3, our a is 3. If you use this equation, that means you will have y over 3 for your vertical stretch. If you use this equation, you will have y equals 3 times f of x. So once again, that's why I like this equation better, because it behaves the same on both sides, but over here it does not. So just remember that if you're using this equation, your vertical transformations behave the opposite of your horizontal transformations. If you are compressing by a factor of 3 or dilating by a factor of 1/3 vertically, you'll have y over 1/3 or 3 times y, or y over 0.33. On this side of the graph, you have y equals 1/3 times f of x, or y equals 0.33 times f of x. So again, just like in the x direction, if you're using this top graph, it just behaves the opposite of what you think. So I hope that that clears things up. I know this is confusing. You guys just have to do lots of practice to get these signs and dilations right. So now that we maybe understand this, I'm going to go through the last few slides on that Desmos activity, in which we were given an equation and we eventually got towards to graphing it. Now there is another couple of videos on going from equation to graph, but I wanted to actually work through an example that you saw in class with you. So we're going to flip screens. And again, I mentioned section 1, your equation looked a little different, but that is okay. This is just, I changed it up because I wanted us to have more transformations. So here we have 3, you guys only had 2. Okay, so first thing we do when we get a problem like this is we want to identify all of the transformations that are happening. So we want to identify what parameters, what the values are for each parameter and how it affects the graph. So let's look at this graph. We have a negative sign in front of the parentheses, outside of the parentheses. We have a +4 and an divided by 3 inside of the parentheses. So we have 2 things happening inside parentheses, 1 thing happening outside. That means we have 2 horizontal transformations going on. We have 1 vertical transformation going on. So let's start with vertical because we only have 1 of them. So the only thing that's happening vertically is we have this negative sign outside of our parentheses, which means that a is actually equal to -1. So we're dilating it by a factor of -1, which means we are going to be flipping over the x-axis. So how you can keep this straight is that remember that when we are acting on y, we are changing our y values and our x values stay the same. So if you imagine a graph, if you reflect something over the x-axis, all the x values stay the same, all the y values are flipped. So when you are reflecting over the x-axis, you're going to be changing your y values, aka you're going to be changing parameter a. So our effect over the graph, or effect on the graph, reflect over y, x-axis, or make y values negative. Next, we have 2 horizontal transformations, which means we know we have h and k. We do not have a b. We are not moving, or we do not have a, sorry, we have 2 horizontal transformations. We don't have a vertical translation. So we do not have a k. There is no plus or minus sign outside of our parentheses, so k is 0. So there is no effect on the graph by k. We are not moving up or down. We are, however, both moving left and right and moving or dilating vertically or dilating horizontally, compressing, or stretching. So we got to figure out what we're doing. Let's start with our plus 4 here. So remember, everything is opposite. If I have x plus 4, that means that my h value is negative 4. So I am moving left 4 units. And I also have a b value right here. Just like the plus and minuses are opposite, division and multiplication are opposite. I have this 3 right here. That means my b is 3. It means that I am stretching horizontally by a factor of 3. And finally, what is the parent function? So if we got rid of all of these parameters, what we would have left is y equals x squared. That's our parent function. Next, let us see how this changes our graph. So first thing we're going to do is fill out some points for our parent function. So -2, -1, 0, 1, 2 are good x values to start with because they're easy to work with. -2 squared is 4, -1 squared, 1, 0 squared, 0, 1 squared is 1, 4 squared is 4. Now we need to find our new x points. And if you notice here, this equation is wrong. This 3 should also be inside of the parentheses. So I'm sorry if that confused you. I just didn't type those extra parentheses. So first thing we need to do, we had 2 things happen to our x variables, right? We know that we are moving left 4, but we're also dilating or stretching by a factor of 3. So just like PEMDAS, you're going to multiply first, then do your addition or subtraction. So here, the first thing we're going to have to do is multiply our x value by our stretch factor. So we're going to multiply x by 3. So we get -6. Then we'll do our translation of -4. So we have -6 minus 4 is -10. So 10. Then we have -1 times 3 is -3. Minus 4 is -7. 0 times anything is 0, minus 4, -4. 1 times 3 is 3, minus 4 is -1. 2 times 3 is 6, minus 4 is 2. Now our y values, we only had one transformation, just a reflection, or as I put in the parentheses, we're going to make our y values negative. So all we have to do is do -4, -1, 0, -1, -4. Then we plot our points. So I'm first going to plot your parent graph, just so you guys can see the difference. So again, we remember this is y equals x squared. So 0 squared is 0. Let's see, 1 squared is 1. 2 squared is 4. And it's symmetrical about the y-axis, so we know it's going to look the same on both sides. So we have something that looks like this. Beautiful. Now let's plot our new graph. So let's just go ahead and plot all the points first. First point, -10, -4. -10, -4. And then we have -7, -1. -5, 6, 7, -1. And then we have -4, 0. We have -1, -1. And finally, we have 2, -4. 1, 2, 1, 2, 3, 4. Here is our new parabola. Oops. All right, so that is how we go from an equation to a graph. And just if you don't believe me, I also have it plotted so you can see it really nicely. This is what it looks like if you plot it with your graphing calculator. Our original parent function and our parent function after we flipped it over the y-axis, dilated it horizontally by a factor of 3, and moved it to the left by 4. All right, if you still have questions, email me or come to my office hours next week, and I hope this helped out, guys.